Hello, everyone, and welcome to another edition of CEO and Market Expert Interviews. I'm your host, Lucian. Some of you know me as Triangle Investor from X. Today, we are covering Nano Nuclear Energy Incorporated, the first portable nuclear microreactor company listed in the United States. I'm joined by their CEO, James Walker. James, welcome to my show. It is great to have you.
It's great to be on the show. Thank you very much.
Thanks. James, why don't we start with your bio? Tell us more about yourself and how and when did you become Nano Nuclear CEO?
Okay, so my background, even though I'm CEO now, I was a nuclear engineer and a nuclear physicist. I used to work for the UK government as one of the engineers that was in charge of the operation and the manufacture of reactor cores for the submarine program. As well as being one of the chief engineers and project managers for the construction of a new fuel reclamation plant. But I was also seconded to Rolls-Royce for a while, where I worked as a physicist in the design of the next generation nuclear reactors for the next generation nuclear submarines, as well as doing some thermal hydraulics work on channel optimization for the next generation of nuclear reactors. But I actually ended up in North America when the nuclear industry looked like it was on the decline a little bit. I ended up in Canada and America doing project management work, building infrastructure projects, and working for capital markets, public companies, and through that network, I actually met the founder, Jay. So he was number one in the company, I was number two, and when we got connected because he was trying to find somebody with some executive experience plus nuclear experience, and there weren't very many of them. So he met me in Vancouver in Canada, and we agreed to have a look at building a nuclear company together. And it was from a very business orientated view. We quickly decided on pursuing microreactors because we saw SMRs were fairly well developed technology, but they were also competing with gas, coal, big nuclear, wind, solar, whereas microreactors were targeting remote destinations where there was just diesel generators and no competition for those diesel generators. We got pushed in that direction, but I think as soon as we started down that route, we realized that there were fuel supply chain issues that involved us in different areas along that fuel supply chain to de-risk our final product. Like we're looking at fuel fabrication, deconversion, fuel transportation. We've even got partner companies that are looking at enrichment. And so that's what we've been doing for the last 2 to 3 years, just building all of that up. And the timing was amazing because there's obviously been resurgent interest from both government and industry pushing money into nuclear. So the timing was perfect.
Exactly. So you are an advanced technology-driven nuclear energy company seeking to become a commercially focused, diversified, and vertically integrated company across 4 businesses, as I see it: cutting-edge portable nuclear reactor, micro-nuclear reactor technology, nuclear fuel fabrication, nuclear fuel transportation, and nuclear industry consulting services as your 4th, right? I would like to cover all 4 of them, and let's start with microreactor technology. Please give us an overview of that technology. How does it work? Fuel requirements? What is the size? Give us some color over here.
Okay. So when we decided to go down the microreactor route, and we thought this is the biggest commercial opportunity because we believe it has the most avenues that this thing could deploy to. We were looking at what a customer actually wants, and we thought a customer actually does not want to buy a reactor or run a reactor or decommission a reactor. So the business model has to be that we sell the power, and if we're selling the power, then the reactor has to be very portable. So it will really need to go on the back of a truck or a ship or a train. We need to be able to get this thing anywhere in the world. So we came up with a design constraint of an ISO container, because that thing can be shipped anywhere in the world. And once we began down that route, we reached out to 2 scientific teams that we believed were the best at doing this exact mission. So the first were professors and scientists out of the University of Berkeley, California. And the second was a team of engineers and scientists out of the University of Cambridge in the UK. But we gave them both the same MO. It's got to be small, portable, passively cooling, so very, very safe. If everything was to break, it would just passively radiate heat, and you wouldn't get the big core melt accident scenarios that you can get with big nuclear power. And so they came up with novel solutions for both of these. The University of Berkeley team removed the primary coolant completely and installed a solid core. So the heat can be thermally conducted through a solid core, and that way you can remove pumps and pressurizers, and the reactor shrinks right down. And the ODIN team out of the University of Cambridge, their solution was to use off-the-shelf components, very high TRL level technology, known coolants, and with the heat generated by the uranium, create a natural circulation of the salt that uses thermal convection to remove that heat to a secondary salt to a turbine. But again, very, very basic technology. Like, you can really, microreactors are as simple as you can make reactors. And that's what we're going for here, because we only want, when we deploy these things, 1 to 2 people on site, and we'll have a central location that can monitor the behaviors of all the reactors, whether it's 100 or 1,000 or 10,000. And so that's the microreactor business as well, and what both teams are working on currently.
Yeah, if I get this right, so you have 2 projects, so to say, ZEUS and ODIN project reactors, and one team is working on one, and the other team on the second one. So, can you tell me what is the current stage of those projects?
So I would say, because ODIN used higher TRL level, technology readiness level components, technology known coolants, and also already licensed fuel, that is that's a more developed design. And so they've moved out of the concept phase and they're building rigs now. So we're going to be able to start showing pictures of like big rigs that we're building at the laboratories. And those will be for the purposes of validating the models, but also data collection to go to licensing. So that's fairly well advanced now, if not leading with any microreactor company in the world in terms of progress. And the ZEUS reactor has started some physical test work as well, but it's still modifying certain things just to optimize that design too. So the way we see it is that the ODIN reactor will likely produce not a cheaper product, but a product that can get to market a bit sooner, can be more easily mass manufactured. But the advantage of the ZEUS reactor is that it operates at higher temperatures. So for things like process heat for industry and remote locations, it's ideal, because generating that kind of 700, 800, 900 degrees is actually quite tricky, whereas ODIN operates at a lower temperature. So low thermal stresses, easy operation, easy to mass manufacture. And so the two will actually complement each other, which is good, because originally to de-risk the business, we pursued 2 avenues to success, but now they actually could be very supportive of each other because of the different operating temperatures and the different potential areas that they could deploy to. So ZEUS, because it's a thermal conduction, no coolant, it's less gravity dependent. So for things like maritime or space or things like that, it could be really ideally suited. Maybe the best possible design physics would allow for these environments.
Yeah. What timeline are we talking here? Let's say in the ideal circumstances, when do you believe that those 2 can be on the market?
Okay. So just to give it a conservative timeline of the reactors themselves, because we've already started the test work and demonstration work on the reactors, I would say that's going to be about a 2-year process. This year we'll start rig work with non-nuclear material, so no uranium involved, and we'll just do validation of things like coolant flows, channels, and that kind of thing. And then we'll progress maybe late next year into using uranium in the reactors that we can just buy in, and then do tests in an irradiated environment.
Sorry. No,
but at the conclusion of that work, we then take all that data and we go to licensing. So there'll already be engagement with the licensing agency before then, but just to give them timelines of what we're looking at. But that 2-year process will be followed by about a 3 to 4 year process through the licensing. And that's a length of time that's given to us by the NRC themselves. So that takes us up to about 2030, 2031 in terms of a final product that's ready for market that we can mass deploy as far as we want. And I think I don't think there's any company that's really going to beat that, because of that long licensing period that's necessary for a product like this.
That sounds really great. Can you provide me some numbers with let's say performance of those reactors, some basic numbers of the performance.
Okay, so on basic numbers, both reactors are really going to output in terms of power about 5 megawatt thermal.
Okay.
And so if you once you convert to electricity, you get down to about 1 to 1.5 megawatt electric. And partially the reason for that conversion ratio is because it's not optimized because of the constraints of the dimensions that the ISO container puts on the system, but we still output at that sort of 1.5 megawatt electric. Now, the advantage there obviously is if we sell to industry that wants process heat, we're selling 5 megawatts. But so this is why the two could be very complementary. Say you have a mining project, the heat could be used in processing work, but the electricity could be used for accommodations, powering electric vehicles. So that they fulfill their decarbonizing mandate in two different areas.
Okay.
In terms of what we expect to sell the reactors for, well, we don't expect to sell them, but we do intend to try and sell the power. And so the metric that we want to beat is the cost of diesel in remote locations. And so when we speak to governments in Indonesia or Philippines or Thailand, and they say, look, we've got island communities that they all run on diesel. There's no other alternative other than diesel. We know that the costs are involved, and we know that the microreactor is fully capable of beating those costs in these remote locations. And that's true for other remote locations we've examined in Canada, but also for remote mining projects, remote industrial projects that have to ship diesel in on a daily basis. It becomes very expensive, it's very polluting, it's very logistically difficult. Microreactors could actually move into all of these areas and push all of these systems out and supply power for 15, 20 years. And that's the other number involved as well, is that the reactor itself can just sit there and output power for 15 to 20 years. But even the burn up of the uranium itself is about 1%. That's how much energy is densely compacted into uranium.
Do you have some rough numbers of cost of production, the reactors and development?
We do, and what I would say is, like, obviously I think these things will change as we define things a lot more, but the first reactor will be expensive, but it will be. But like the business models show that even after about 8 to 12 of these off a production line, those costs become they rapidly decrease. And so when we were modeling for producing 20, 30, 50, 100, then the cost can come right down to the point where some of the locations we were looking at that use diesel, we would beat out the cost of a year's worth of diesel in 1 year, as an example. Like one location we were looking at in northern Canada had a community of 800 people, and the diesel costs alone for that community was about $10 million a year. Now, within 1 to 2 years, the reactor will be more economic than just doing that, because so while I'm reticent to obviously give definitive numbers at this point, because they will change, it's looking very likely that economically we can beat out these remote costs fairly comfortably.
So does your company have any other patents or projects in pre-development when it comes to small reactors design or similar?
So we do have patents on some of the design work on the reactors. There are other patents that we also have on other technologies. We've got patents on transportation baskets that can move commercial quantities of HALEU fuel. Because if we know we're going to move a lot of these reactors, we want to be able to move the fuel as competently and as quickly as we can internally without reliance on third-party vendors. So we have patented technology on that. We've got patented technology on ways to move molten salt, solar salt without the use of pumps, so electromagnetic systems. And we've also pursuing patents on some innovative sensor related products that can go into high temperature reactors, because that's one of the big difficulties, is that sensors in high temperature environments don't really function very well, and there can be a big problem with monitoring behavior. But we believe we've identified ways to get around that issue. And there are other technologies we're working on that are a bit less developed, but we want to obviously create a product line of things that we can then go and license to others as well that will actually help them. So things that we're doing with salts that'll be very beneficial for the SMR companies is something we'd be very happy to share. And even with SMRs, there's actually no real competition between the two of us because we're targeting different markets, and so there can be an alliance between the two companies for sure on that.
I can see that. You mentioned HALEU. Your company has a subsidiary called HALEU Energy Fuel Inc., which is focused on the development and manufacture of high-assay, low-enriched uranium for its reactors and SMRs. So where is this on your priority list, and what are you currently doing over there?
So this is quite a high priority, and the reason why it's a high priority is that we've observed that there are enormous fuel sourcing issues in the United States, and that principally came about because the US was buying weapons grade Russian material, and it was taking that material and it was down blending it to meet its domestic needs. But like obviously now that supply has been severed, and the US has stockpiles now that it'll utilize, but it needs to build back its infrastructure. But for HALEU fuel, there's currently no way to manufacture final fuel forms that can go into SMR or microreactor companies. And so this has actually brought this caused us enough concern where we did speak to the Department of Energy and the national labs about solutions for this. And from speaking to the high level leadership, they were the ones that said, look, nobody else is working on a non-TRISO HALEU fuel fabrication facility. If you were to move into this area, you would significantly de-risk your fuel supply. You could fabricate a fuel and the composition and the dimensions to your own reactors, but it could also be an alternative business line that could supply others. And so, although we started with microreactors, we were quickly pushed in the infrastructure route. And so we've now identified the land package, we're building up the design team. And so as soon as those final things are finalized, we're going to get going on it. So it will be this year that we start really serious design work on those facilities. And we've got big construction partners that want to work with us. And even when we speak to the Department of Energy, they're very supportive, and there are these financing facilities that are available from them to support this kind of endeavor. So we'll get building this thing as quick as we can now. Now that we know where we want to build it, and we've got the design team, we're just going to put and the IPO is now done. We can just get going on that design work and start building.
Sure. Can you please tell me more about your other subsidiary, Advanced Fuel Transportation? What is it all about?
Yeah, so that came about because it's one thing to be able to like manufacture the final fuel form that you need for your reactor. But say you're moving quite a lot of reactors around the country, you also need to be able to move a lot of fuel. And what we really needed was to be able to have one container move all the fuel that the reactor would need. And we didn't see a way that we would have control over moving commercial quantities of that HALEU fuel ourselves. So we actually bought patented technology that had been developed by the national labs, so INL, ORNL, PNNL, but had been funded by the DOE. But that research had been shelved. So we went out and we bought the exclusive license to that patented technology. And what we want to do now is, it was designed around uranium dioxide, but we want to adapt it so it can accommodate all other fuel forms. So we'll need it to move metal, and we'll need it to move hydride at the very least for our own reactor systems. So we'll adapt the basket to be able to accommodate those. And around the logistics of moving HALEU fuel, we've some of our initial investors were the former executives of UPS. So we've actually brought them in to help with the coordination and the development of a transportation subsidiary, just to be able to move our fuel around for the reactors and the deployments. And that'll include adapting that basket design to be able to move spent fuel as well. So we can decommission the reactor, remove the fuel, and all that kind of thing. So even this could very likely transform into another business for us as well, because even if you're in enrichment or you're in deconversion or if you're in fabrication, you're going to need HALEU fuel moved. And almost all the modern designs for these advanced reactors use fuel that's enriched over that 10% mark, so Cat 2 level fuel. And that's ultimately what we want to target and make sure that the capabilities exist so that we can move that material around. So advanced fuel transportation grew up out of that necessity and that de-risking of the business to be able to move the reactor plus its fuel around the North America. But there's no reason why it couldn't be the same technology couldn't be utilized in Europe or Africa or Asia or anywhere. So.
Yeah, got it. Your company also provides consulting services. Who are your clients here, and what percentage of your future revenues will come from that segment?
So our first revenues will definitely come from the consulting arm of the business, and we have some contracts that are starting later this year. We haven't publicly announced them yet, so I don't want to say who they are.
No, I didn't
Um,
mean names. I mean,
yeah.
what kind of groups, what kind of
Oh, so
companies?
there's going to be there's some government level, so we're going to be working in partnership with the government. Those are going to be some of our initial contracts that we do with them.
Yeah.
Um, but some of the things that we're looking at will actually be looking at installing certain technologies within other reactor systems. Um, and there's also going to potentially be an international arm that looks at the training of individuals for countries. So we've got an MOU coming up with a certain country that is looking to try and educate a workforce in nuclear. And there's going to be a contracting and educational element around getting up some of the native people of that country to up to speed with reactor operation, reactor development, and the nuclear industry in general.
Mm-hmm.
So it's going to be a combination of private industry and government to begin with.
Yeah.
But I think importantly for us, we want to get this facility up and running and build it up as much as we can, because the more revenue generating you are, the more de-risked the company is. And we don't always want to be reliant on the capital markets or funding opportunities or grants or loans. We want to be as self-sufficient as possible. So, and it's come at a good time when there's a huge demand for nuclear expertise and there is a shortfall of personnel. And so this, we believe we could expand this pretty quickly and build up the not just the first revenue in the company, but a substantial revenue portion of the company. In terms of what percentage that'll be of the overall revenue, it's very difficult to say because it's difficult to estimate the market size of fuel movement or fabrication just yet, because it's also reliant on who succeeds in getting licensed products made. But in terms just, I still think the microreactors are the $1 trillion cherry on top of the sundae right at the end. But certainly, I think we can become very comfortable as a company and very established through the consultancy side just alone, before we get to those secondary, tertiary, and final revenue stages with transportation, fabrication, and the microreactors.
Okay, so the first revenues will come by the end of this year, and you expect to be positive cash flow in the next year or the next one, approximate revenue projections.
Yeah, I mean, certainly the revenue will be expected later this year when it will first start, and we'll be obviously begin building that up. So each year should be an increase on top of that. Revenue positive, we're probably going to be spending a lot more on R&D than the revenues will be generating, or at least tied at the very least, because we've got a lot of areas to develop. And as we go into things like demonstration work that uses nuclear fuel, like enriched HALEU uranium, some of those costs will obviously climb up a lot, but we're in a very strategic position. So the reason why we listed early is so we could structure the company with a small market cap, a small float, and as we release news, we grow with the public. And it was a much more de-risk strategy than doing some of the other strategies that the other nuclear companies have done, where they've listed as a SPAC with a large number of outstanding shares and a large float, but with also a high market cap. And those things can be very susceptible to shorts, which can drive down share price and make it very difficult to raise further money. But we've structured it in a certain way where appreciation of the share price is very likely, and structured so that will happen, so that raising more significant capital could be done at much higher prices for infrastructure projects without causing too much dilution. So while we'll be revenue generating, we are public and we will have the advantage of the capital markets there that we can go to at an institutional level as well. So the big institutional investment firms of the world, as we begin building big infrastructure projects, these are the things they want to be involved in. like national capabilities. And so then we can go to them and raise significant capital. And that won't be, even though that might be somewhat dilutive, it'll be less dilutive than doing it straight away. And it'll be non-debt financing too. So it just further de-risks the company. So the financial strategy has been very carefully worked out just so we can optimize and grow very quickly in a short amount of time. So.
Yeah, you mentioned stock. Your stock performed very well in the last couple of days, weeks. What do you think? Why was that? And do you see that trend continue?
So it's interesting because we expected it to happen. And the reason why I expected it to happen is because the float is very small. So sort of a 3 million share float. And when you get that sort of thing, you get a pinch on demand, and that can spike the price. And obviously, that's been very deliberately done because we want to be able to build up. So it wasn't unexpected, but like certainly how quickly it went up was a surprise. I don't mind admitting, because we anticipated a very gradual growth. And certainly, I think some of the enthusiasm and public announcements coming out of government, Biden's administration, the tech industries, general industry in general, are all about nuclear and how positive it was. It was putting a lot of investor focus into the markets and nuclear companies in general, especially low cap market ones. So I think this was also behavior that was observed in a few other nuclear stocks too, where they also spiked up just because of that consumer interest. And stocks are interesting things because then they're investors' estimate of what you should be worth in the future. And so you can see that the stock market at the moment is making a big bet on nuclear, because if the stocks are rising, they're investing in the future of it because they believe it'll thrive. And ultimately, the uplift in Nano stock price was a reflection of that belief that it's a bet on the future, and the future will be nuclear. And it's further validation of our company too, that it's also a bet that this company will also succeed and be part of that nuclear environment in the future. So it's obviously wonderful to see. I didn't expect it to rise that quickly, but obviously, I mean, nobody complains. It's great to see. So.
Yeah, you had a raise recently. How is your cash position after the raise?
So it's very comfortable now. I mean, we've got plenty of money we need to get on and do everything we needed. And we only wanted to raise a small amount, so I think we did $10-11 million on the most recent round. But that was to cover principally rig construction work, non-nuclear, for the reactors systems, design work for fuel fabrication facility, further design work to change the basket design so it could accommodate other fuel forms, and also working capital that we would need for promotion of the company, but also development of other technologies and the building up of the consultancy business as well. Bidding on contracts, that kind of thing, expanding the workforce. As far we raised exactly what we needed to do to expand and have enough breathing room, and ultimately, when it does get to a much higher share price, and you go to institutional level, these are the sort of shareholders you want because they hold, and so it goes up a lot higher. We go and raise a significant amount for infrastructure to start site preparation work, construction. That'll be the next phase that we go to. But so far, we've raised enough to be very comfortable and be able to work very without much stress on the financial side, which is great. And part of the benefit we've got here is that, say, the founder has a Wall Street background and has a banking background, and that's been of enormous benefit for the structuring of the company and being able to actually acquire the funds necessary to build like in a coherent way.
So you would say that the interest for this financing was good. I mean,
yes.
who bought the stock? Was it big names, funds, or smaller investors? Without any names, just to get the start.
Yeah, there were funds involved. There were some Silicon Valley funds as well that came in. Some of our initial investors were involved, and there was also a Forbes billionaire who was also involved in that raise as well.
And what about insiders? Were insiders in the finance?
Yes, they were. So, like, I think we all put more money in. Certainly, the main management, because just being able to invest just beforehand, and we were, I think I can't remember what we were raising at now, but we knew that once it hit the market, within a few months, obviously we would see an appreciation. So insiders were also involved. I can't remember the percentage, but there were funds, there was billionaires, and there was retail as well. There was actually quite a lot of people that directly contacted us wanting to be part of the pre-IPO round. So
yeah, that's great. That's great. Future news flow from the company. What and when can investors expect some news going forward?
So immediately following a listing, you have a blackout period with the NASDAQ.
Yeah.
I think that's almost over. I just need to check. So some of the news we have coming up, we'll obviously put out after that sort of blackout period, but there'll be announcements about personnel, about sites that we've identified. There'll be about technology, about partnerships. There'll be things about consulting work. We've got a lot of news flow. So like the good part here is that because we've been working on so much, we should have a steady stream of this just to keep people interested. But obviously I can't give away the titles before it's publicly disseminated. But there's yeah, we've got quite a lot backed up, which is quite nice. So
okay, my final question, you mentioned marketing. How will you tell this story to investors? What are your marketing strategies to improve the picture of the company to retail investors?
So we've been trying to do this on a multi-pronged approach. Obviously, programs like yours are incredibly valuable because it's about getting the message out there too.
Yeah.
And if you do programs like yours with different sectors, like one for tech, one for environmental, and you keep doing like that, you can give a different message each time and not just spread the word about the company, but also improve the sort of sentiment around nuclear, which I think is actually quite important.
Yeah.
But we also do a lot of conferences. I do a lot of speaking engagements, panel discussions, speeches at these events. In fact, I've got one coming up tomorrow in Boston. And I think I've got another one in Las Vegas a bit later this month. And so there's a steady stream of public engagements where we want to speak about the company, what we're doing, and it's also about brokering relationships too. We don't really want to be in competition with a lot of the other nuclear companies. The more partnerships, the better. It's a very small environment where everyone kind of knows each other. And I think if one succeeds, then everyone benefits. And so part of the collaboration is also building friendships and relationships with them so we can collaborate to make sure that we both succeed. But yeah, it's a combination of different things.
Yeah. That was James Walker, CEO of Nano Nuclear Energy Incorporated. James, thank you for coming to my show. It was a great chat, and I hope to have you as my guest soon again. Thank you.
Thank you very much. It was great to be on.